the session on fuzzy AHP. We already started a session, and we have a detailed lecture on fuzzy AHP today, and training on this software. There is software on which we have hands-on training. So I will request all of you students to have a laptop and perform this analysis with me. And before that, we will start from this some introduction and some details that how we apply this method. After that, we will proceed with software. And here we see that fuzzy AHP is a basically AHP based method in which we have a similar steps, but a few different steps in which we have a different scale and some other analysis I will describe you. The essence of AHP method is in comparisons of pairs of stacking attribute values. As we discussed that we perform pairwise comparison in which we have set criteria, and there is a comparison between two factors or criteria, and this is similar we perform in fuzzy AHP. It is performed by making comparisons between pairs of values of certain indicators while asking which of two compared indicators is more important and how. So this is the basics of this method, that how two factors are compared and how much importance one has to other. So this is, I already informed that it is expert based analysis. So we mostly get responses from the experts' opinions. It's not like general analysis in which we get a lot of data, and the data is sometimes results are not so consistent. But in this analysis, even we have few number of participants, but still we can get very reliable results, because these multi-criteria decision-making techniques are all decision-making techniques. So we get responses from experts and their opinions on some specific problem. How can we solve it? Therefore, we apply these techniques. In methodology and about this technique, this is used to evaluate the significance of selected criteria for particular goal. This fuzzy analysis is performed in which we calculate the weights and rank the criteria and sub-criteria based on AHP model and fuzzy scale. Previous we discussed that how we develop hierarchical model on which there is a goal on which we assume that for some specific task we want to do, and then how we set criteria related to it and sub criteria. So this is the concept that in which we have a fuzzy scale in this, and in AHP general technique we have Sate scale. So this is the main difference in these techniques. In Sate scale, we have the crisp values in which we directly say 1, 3, 5, 7, 9. But in fuzzy scale, we have fuzzy values in which there is a three set of values, and we can further say that how much is one criteria is important from other. So this is the difference in both techniques. But AHP is the most widely used technique, and fuzzy is also related to it. So we can further, it depends that what kind of problem we are going to solve. Here we can see in the figure that first we set our goal, then we have a criteria and sub-criteria identification. Then there is a hierarchical structure in which we arrange these criteria and sub-criteria. Then we perform pairwise analysis on the software. uh, I will show you that how we perform the software based on the responses on particular questionnaire scale. Then we measure the weight vectors evaluation also. We get these values from software, and then finally defuzzification and final ranking of performance indicators. In this process, we calculate the final weights, and then we rank them accordingly, that which is the most significant criteria and which is the least significant criteria based on all the measurements and calculations. So this is the procedure for this method, fuzzy AHP method. Here I show the first step in which we set the criteria and sub-criteria. In first, you can see that there is level 1 in which we set that what is our objective. For example, I will show today that how the driver behavior criteria affects road safety, and this is, for example, our objective, that how we can categorize that which criteria is the most important factor which affect the road safety. In criteria 1, criteria 2, criteria 3, we give them classification, what our objective related these factors which affect our objective, and this we can call it level 2. In level 3, we can give solutions to our problem, that based on these criteria we have solutions, and which solution is most effective based on which criteria. So this is the first step we start whenever we apply these AHP methods and fuzzy AHP technique. So this is it's just written criteria 1, criteria 2, criteria 3, and alternative 1, alternative 2, alternative 3. Basically, on these criteria, we put our factors which we are going to analyze, and in alternative, we perform different solutions: solution 1, solution 2, solution 3, whatever problem we have, and what are we analyze and proposing the different measures and solutions. In the whole procedure, we will discuss each step one by one, that how we measure the weights based on these criteria. As the first step is the comparison of factors. The calculation of the weight factor with fuzzy AHP method can be described in the following steps. As we have to measure the weights, final weights at the end, based on which we can say that which factor is the most important one, and how we rank them, that this is on first one and this is second, third, and the which one is the least important factor. So these weights are very important. We should know how we measure them. Based on expert opinion, the pairwise comparison of factors is being prepared. The experts are required to compare each factor in pairs in a matrix form with size n by n, which n is the number of factors. So here we see that in the matrix we can see that there are some factors r11, r12, and so on. We can have number of matrix size like 3 by 3 matrix, we can have 4 by 4, 5 by 5, and more. Comparison of experts are in the scale of 9 values. So in fuzzy scale, we have 9 values: 1, 2, 3, 4, 5, 6, 7, 8, 9. Also, we in Sati scale we have 9 values, but in fuzzy scale we have in triangular values 3 values, and this is a bit different scale than Sati scale, and they are denoted by Rij. The results of the comparison of experts are grouped into a pairwise comparison matrix using the average mean. So the procedure is simple, like we take the average mean of the these all responses on what we get from the experts, and the system and the software do itself the comparison. So comparing values in pairs expressed by fuzzy linguistic values, we call it linguistic values, and this is like fuzzy language. So these are basically numeric values we used for these comparisons. In step 2, perform the test of consistency, and after getting the weights, then we proceed for the consistency test. In order to control the consistency of subjective opinions and accuracy of the weight factors, it is necessary to calculate the factor of consistency factor, who is defined as CF is equal to lambda max minus n over n minus n, where lambda max is the maximum eigenvalue of the matrix R and n is the number of factors. So this is the procedure we already in previous lecture show that how we measure lambda max, and this consistency factor we should know that it should have a value less than zero point 0.1 or 10%. Then we can say that the pairwise comparisons are acceptable. In the previous lecture, you can see in online video that there is the whole procedure, that how we first take the sums of the in the matrix, and then we divide the each row by a total sum, and then we take the means, and then we measure these lambda max, and then we calculate consistency factor. But in software we get directly these values, because in it's already in the software, and we have to only insert the responses of the experts. So the next step is converting parameters in fuzzy number. The values of pairwise comparison matrix are converted into triangular fuzzy numbers in accordance with the rules of conversion. So in this fuzzy AHP, the main concept is to convert these responses of the experts into triangular fuzzy numbers. Like in Sate scale, we have direct values 1, 3, 5, but in fuzzy scale, I will show you in the next slide that we have three values, and the expert have to select one from these values. So it basically overcome the uncertainty of humans. If someone say that one parameter has importance, then someone may ask how much importance this one have. Then he can, using this scale, he can describe that it has much more importance or weak importance, like this. So calculation of the true values of the weight factors, and then we apply final analysis, and we can measure the global fuzzy weights, and based on that we can rank our criteria. Before, in step 2 and step 1, these weights were the weights, we call it local weights, and in this step we call these global weights. Based on global weights, these are the final weights on which we have the ranking of our criteria. So this is the scale which I discussed, linguistic fuzzy scale, in which we have these values. You can see that in real value there is only one value, and in fuzzy value you can see three values. So in fuzzy value there is more option, that if someone say there is absolutely strong importance of a factor, then it can be 9, or it can be 8, or it can be 9 in between these two values. So this relation have three optional values. In very strong, we can see that there is 7. Then fairly strong have a real value of 5, and in slightly strong there is a value of 3, and if both pairwise comparison factors have equal importance, then we can say that it's have equal importance for both factors. But if we can say that 1 by 3, then this factor has, we can say that it's 3 times less important than the other factor which we are performing pairwise comparison. In fairly weak 1 by 5, and very weak 1 by 7, and absolutely weak we can see that it's in 1 by 9 value instead of direct value 9. So we have, you can see that more values, and we can have a better understanding from these values that how much important is one value as compared to other. So this is the fuzzy scale we use. In more description, we can see that this triangular fuzzy number, we have three values like L show for low, M is the medium value, N is the high value. So from these we can say that which value someone select, middle value or low value or high value. So in the table you can see that for perfect someone, you can say that you see in the previous figure, someone say 9 as absolutely strong value, someone say it's perfect value. So they have a similar meaning, that it's if someone is saying absolute value, it means very strong relationship, and if someone say very good, then it has this number 5 to show these numerical values for this scale. So this is fuzzy scale, and the Sate scale we already discussed in our previous lecture. This is the procedure we have. First to arrange our factors in hierarchical tree, and we can say it hierarchical AHP model. In step 2, we create fuzzy pairwise comparison matrix, and in third step, check for consistency for the most likely value. If the results are consistent, then we proceed to our next step. If these are not consistent, then we can change the criteria, or we can ask experts to have a better opinion. Then next we proceed calculate the fuzzy weight. If then we have aggregate individual preferences, then we go for fuzzy defuzzification, and then risk attitude, and then final ranking and decision making. So this is the whole procedure we use for this fuzzy AHP technique. And the most important is that how we select the criteria, and based on the previous studies, that which criteria are the most important and which are related to our project, or which the problem we are going to solve, and the expert use these criteria most of the time, and how they respond on these criteria. After that, they have we go for pairwise comparison, and that is can be number of pairwise comparison can be 30, 40, 50, but it should be not much high, because it affect the results and it make them more complex. So then we check consistency. I will show these steps one by one in the software, in which how we perform these steps, and how we calculate the final weights, and based on these weights how we rank the criteria. So in summary, we have this comparison in which we have two scales, basically Sate scale and fuzzy scale. In Sate scale, we have crisp values. We can say that these are the exact numbers. And in fuzzy scale, we have a range that we have high or low values or in between value. So handle uncertainty. In Sate scale, it says no. In fuzzy scale, it says yes. And example value, it shows 3 for moderate importance. And in fuzzy scale, we have three values, 2, 3, 4. So it's like better range of values to select and to cover uncertainty. In mathematical complexity, it shows that it's simple, and fuzzy scale is bit higher technique and best for clear and confident judgment. It's we have to apply Sati scale, and for uncertain or subjective judgments, we have to apply fuzzy scale. So this is the main differences in both techniques, and any technique depend upon which we have to select depend on the type of judgments we want to made. In defuzzification, it's important to explain here the final step that converts fuzzy, uncertain judgments into clear numeric priorities for decision making. So this final step is like bit show that if it's fuzzy scale, then why we uh, go for defuzzification, because we convert the values into a clear numeric priorities, and based on that we can say that which criteria is more important as compared to other. So this is sensitivity analysis, in which the after all the steps and after the whole fuzzy analysis, we can check that how the if changes occur in criteria, it affect our final ranking. Sometimes if the problem is time to time change, for example in traffic system, some new technology evolves and we apply, like you can say that in if motorway there were manual tolling and nowadays automatic. So if such changes occur, then how our analysis reacts to these changes. So this check for this sensitivity analysis is a check we apply at the end, that how it affect the final ranking of alternatives. AHP sensitivity analysis is a method used in AHP to assess how changes in criteria priorities affect the final ranking of alternatives. The purpose of sensitivity analysis is to measure the consistency in selecting the best alternative in different conditions. So we check that if our results are sensitive to change in criteria and how much change occurs, then accordingly we take the decision. For example, in this table we can see the sensitivity result. If ranking unchanged, then robust decision, stable and reliable. It means no need to change any analysis. If minor ranking changes, then still moderate sensitivity, still acceptable. But if top choice changes easily, highly sensitive, then we need to recheck, and we may apply again the whole procedure, and we can apply the pairwise comparison, and we can rank the all the criteria accordingly. In a figure, you can say that how these criteria affect and which criteria is more sensitive. You can see that this green line has more fluctuation, which shows that it affect more on the ranking. And if we see that if different software, how these shows that which factor has performed the sensitivity analysis and how it affects the final results. So some researchers use this sensitivity analysis at the end of their particular research to show that our results are reliable and we can use for decision making. So this is a very important method to apply. In summary, multi-criteria decision making is a powerful tool used widely to solve problems containing multiple conflicting criteria. Among numerous methods of multi-criteria decision making, the fuzzy AHP is very suitable for evaluating alternatives when qualitative and quantitative advantages are expressed only with the linguistic vagueness. So if we have a number of criteria and there are different factors and we need to apply pairwise comparison and then how they have importance one to other, then these techniques are very useful because in manually we have to perform a lot of analysis and we have a complex procedure to show that which criteria has importance, the most importance. So in this method it automatically give us the most significant one and the least significant one criteria. A disadvantage of fuzzy HP method approach is that input data expressed in linguistic terms rely on opinions and experience of decision makers and thus involves subjectivity. So there is disadvantages of any technique. So this has bit disadvantage that if someone has in from if we have 10 experts, each one has different experience in for different problem solving. So it depends that how he will respond to this particular problem. So that's why there is subjectivity issue that someone has his own opinion and it can be reliable or not. It depends to our and it can affect our results. So this is the software super decision and V32 and this is commonly used for these multi-criteria decision making techniques. So we already discussed that AHP is the most widely used technique. So there is another technique we call analytic network process that is also used for these kind of analysis. This software provides tools to create and manage AHP and ANP models, enter your judgments, get results, and perform sensitivity analysis on the results. So this is a full package in which we can perform pairwise comparisons and also we can get results and ranking of the criteria and then sensitivity analysis is also performed as I say that it shows that how sensitive are our ranking if criteria are there are changes in the criteria. So with fuzzy AHP software we have to draw hierarchical charts first one, then select or create your own fuzzy scale and then fill the pairwise comparison tables and then obtain a complete report. So this software help to get all these results from our selection of table. So this is another tool, online tool, in which we will perform fuzzy AHP software. You can see that there is also other analysis we can perform in this software. AHP software, fuzzy Topsys software, and Topsys software, fuzzy Vcore software, and Vcore software, fuzzy D metal software. So these techniques are bit different from each other, and there is sometimes more which these cover more uncertainty in different techniques and we can change these techniques one by one that which problem we are going to solve and which technique will be according to our problem solving. So we if we learn AHP and fuzzy AHP, then other techniques are also easy to understand because the procedure is same. We have to develop first model, and then we have to perform pairwise comparison, and then we find results. But the basic difference is the selection of this fuzzy scale or saute scale, and these kind of differences we have. Here you can see that this is the example. For example, we will perform on the online this software. Its name is online output. You can start from your laptops and insert this online outputs, and then we will continue together that how we perform analysis on this. But of course, in the we will perform this software in demo version. The full version you can also perform. It depends that you want to perform some project or analysis, and you can purchase the full version of the software. But it's easy to perform. We can learn easy today, and you can perform any type of analysis of multi-criteria decision making, and it will show us the results. For example, today we will have example of related to road safety, that how driver behavior factors affect the road safety. We have main factors for driver behavior, for example lapses, errors and violations, and these factors can be, for example, further divided into sub criteria. Of course, we have two other types of violation: ordinary violations and aggressive violations. Then how we can control these type of driver behavior factors from engineering point of view, from education, enforcement. For the, we have three E techniques in which we apply engineering, education, and enforcement. So you can see that in criteria, for example, someone selects 7 in you can say that in interpretation you see that if someone selects 7, then its mean A is very strongly more important than B. So we take it from rows to column. So in -3 in AD, we can say that A is moderately less important than D. So if we want to give negative value, then it has less importance than the other. You have two options. You can say that you want to give negative value, or you can give 1/3 value to show the reciprocal of 3. It shows the reciprocal of 3. So it means in the software you have to put the minus value if someone has less important than the other. If you place the positive value, then it has positive and moderately, for example, more important, strong important than the other. So this is the difference of selecting positive and negative values in the software. So keep in mind that if A is on the left, for example, one criteria, and one is on the other axis, then you have to consider on the left column that this criteria is how much important than the other. For example, here it shows interpretation. So we will proceed to the software. I will show the screen. So if you have laptop, then we can proceed. जो है ना वो हमसे पूछेगा कि जी आप अपनी आईडी से लॉग इन करना चाहते हैं, तो फिर हम प्रोसीड करेंगे नेक्स्ट, और इसमें फिर सारे ऑप्शन नेक्स्ट आ रहे हैं कि न्यू प्रोजेक्ट स्टार्ट करना चाह रहे हैं और कैसे अप्लाई करेंगे, ये टेक्निक जो है ना इसमें आज हम अप्लाई करेंगे। तो ये इसमें देखते हैं कि जी किस तरह से फजी AHP की एग्जांपल है, इसमें मैं आपका करके बताऊंगा कि जी कैसे प्रोसीड करेंगे, और उसके अकॉर्डिंगली फिर जो है ना आप अपना प्रोजेक्ट वगैरह इस पे परफॉर्म कर सकते हैं। تو یہ جو ہے نا اس کو بتائیے گا کہ جی کس طرح سے آپ اس کو پرفارم ساتھ ساتھ ایزی ہے آپ کر سکتے ہیں. ٹھیک ہے جی. اور یہ سافٹ ویئر آن لائن جو ہے نا اس میں آپ دیکھ سکتے ہیں کہ کس طرح سے اسکرین آپ کو جو ہے نا اس میں ویزیبل ہے کہ کس طرح سے نیو پروجیکٹ میں جا کے آپ نے اس میں سٹارٹ کرنا ہے. اور اس میں دیکھیں آپ کو ڈفرینٹ ٹیکنیکس شو ہو رہی ہیں کہ جی اے ایچ پی ہے اور ڈی ای اے ہے, فزی اے ایچ پی ہے, اور اس کے اکارڈنگلی جو ہے نا آپ نے ٹاپسز ہے اور دیکھیں گے کہ کون سی ٹیکنیک آپ جو ہے نا اس میں اپلائی کرنا چاہ رہے ہیں. تو آج ہم جو پرفارم کریں گے وہ فزی اے ایچ پی ہے. اس میں ہمارے پاس جو ڈیمو ورژن ہے وہ اس پہ جو ہے نا ٹرائی کرتے ہیں. ٹھیک ہے. پھر اس میں آپ فردر انالیسس بھی پرفارم کر سکتے ہیں فل ورژن میں. تو اس میں فار ایگزامپل ڈرائیور بیہیویئر کرائٹیریا افیکٹنگ روڈ سیفٹی ہمارا آج کا یہ پروجیکٹ ہے. تو اس میں ہم سیکھیں گے کس طرح سے ہم فزی اے ایچ پی جو ہے نا پرفارم کر سکتے ہیں. تو یہ اس میں آپ کو میں نے بتایا تھا کہ سب سے پہلے ہیرارکل اسٹرکچر جو ہے نا وہ ہم ڈیولپ کرتے ہیں. تو وہ سب سے پہلے آپ اس میں ڈیولپ کریں گے کہ ہمارا گول کیا ہے, اور اس میں نمبر آف کرائٹیریا سیٹ کریں گے جس طرح اس ٹیکنیک میں سیٹ کرتے ہیں. اور سب سے پہلے ہمارا جو گول ہے وہ ڈرائیور بیہیویئر فیکٹرز افیکٹنگ روڈ سیفٹی ہے, وہ ہم اس میں اپلائی کریں گے. اور نیکسٹ اس میں ہمارے پاس جو اس سے ریلیٹڈ فیکٹرز ہیں وہ اس میں ون بائی ون ہم انسرٹ کریں گے. سب سے پہلے جو ہمارے پاس مین فیکٹرز ہیں وہ آ جائیں گے. ہمارے پاس لیپسز ہے. فار ایگزامپل لیپسز کا آپ کو میں بتاتے چلوں کہ یہ ایک فیکٹر ہوتا ہے جس میں ڈرائیورز جو ہے نا وہ ان کو یہ ہوتا ہے کہ جی وہ بھول جاتے ہیں کس جگہ گاڑی پارک کی تھی, یا ان کے مینٹل پرابلم ہوتا ہے کہ جی کوئی ان کو سمجھ نہیں آ رہی ہوتی کہ وہ رانگ لین میں موو کر رہے ہوتے ہیں. تو ان کو جو ہے نا یہ لیپسز وغیرہ جو ہے نا ایج کے ساتھ یا کوئی مینٹل پرابلم ہو تو اس میں وہ یہ ڈرائیور بیہیویئر کا ایک فیکٹر ہے. ایررز کا جو ہے کہ کوئی مسٹیکس وغیرہ جو ڈرائیونگ کرتے ہوئی کوئی کر دے اور کوئی جان بوجھ کے نہ کرے تو وہ ایررز میں آتا ہے. اور ایک اور اس کی ٹائپ ہوتی ہے وائلیشنز جو ہے وہ آپ کو پتہ ہے کہ کوئی یہ جان بوجھ کے کوئی مسٹیک کر رہا ہو اور کوئی سپیڈ وغیرہ کی لمٹ سے زیادہ جا رہا ہو, کوئی ٹریفک سگنلز وغیرہ کو بیٹ کر رہا ہو, تو یہ اس میں آتا ہے. اس کی آگے فار ایگزامپل ہم چاہتے ہیں کہ اس کو فردر دو ٹائپس میں ڈیوائڈ کرتے ہیں جس میں آرڈینری وائلیشنز ہیں اور اسی طرح ہمارے پاس اس میں جو ہے نا اگریسو وائلیشنز ہیں. تو اس میں فردر اس کو ڈیوائڈ کیا گیا. تو اسی طرح اگر آپ فردر ان کے سب فیکٹرز کرنا چاہتے ہیں کر سکتے ہیں. جیسے کہ میں نے بتایا لیپسز میں اگر کوئی رانگ جو ہے نا اپنی گاڑی پارک کدھر کیا وہ بھول جاتا ہے کہ وہ اس کے مینٹل سے ریلیٹڈ ہے, تو آپ اس میں فردر ایڈ کر سکتے ہیں. اسی طرح ایررز میں آپ فردر ایڈ کر سکتے ہیں کہ کسی نے ڈسٹنس جو ہے نا وہ پراپر انڈرسٹینڈ نہیں کیا کہ جی کتنا ڈسٹنس سے گاڑی آ رہی ہے اور اس نے غلط ٹرن لے لیا جس کی وجہ سے کوئی ایکسیڈنٹ ہو سکتا ہے. تو یہ اس میں ایررز میں آ جائے گا. اسی طرح آرڈینری وائلیشنز ہیں کہ کوئی چھوٹی موٹی جو وائلیشنز ہیں وہ کسی نے اپنی لین چھوڑ کے یا بار بار لین چینج کر رہے ہیں. اگریسو وائلیشن ہے کہ جیسے کہ سپیڈ کی وائلیشنز ہو سکتی ہیں اور کوئی رانگ لین میں موو کر رہا ہے تو وہ ہو سکتی ہے. اسی طرح کوئی سگنل جس نے بیٹ کیا وہ ہو سکتی ہے. تو یہ اس کی آگے فردر ٹائپس ہیں وائلیشنز کی. تو ان میں سے آپ نے فار ایگزامپل ایکسپرٹس کو دینا ہے کہ جی ان کے نظر میں سب سے امپورٹنٹ کرائٹیریا کون سا ہے اور سب سے لیسٹ امپورٹنٹ کون سا ہے، تو اس میں ہم کہتے ہیں کہ جی یہ پیئر وائز کمپیریزن جو ہے نا ہم اس سافٹ ویئر میں ہم پرفارم کرتے ہیں۔ اس میں آرڈینری اور ایگریسو وائلیشن کے درمیان اگر پیئر وائز کمپیریزن نہ ہو رہا ہے تو یہ دو فیکٹر لیں گے، اگر لیپسز اور ایررز کے درمیان میں پیئر وائز کمپیریزن نہ ہو رہا ہے تو وہ اس کو کنسیڈر کریں گے۔ بہرحال ڈیپینڈ کرتا ہے کہ آپ جو ہے نا یہ کوشچن کس طرح سے ڈیولپ کر رہے ہیں، کتنے فیکٹرز لے رہے ہیں، اور پھر جو سافٹ ویئر ہے وہ اٹ سیلف جو ہے نا کرے گا پیئر وائز کمپیریزن۔ وہ ڈپینڈ کرتا ہے کہ جی 30 پیئر وائز کمپیریزن پرفارم ہو رہے ہیں، 40 ہو رہے ہیں، 50 ہو رہے ہیں، اس حساب سے الٹرنیٹیو ہم ایڈ کر سکتے ہیں اس میں، اور الٹرنیٹیو کا ہمارے پاس آپشن ہوتا ہے کہ جی اس میں ہمارے پاس کس طرح کے آپشن ہیں۔ فار ایگزامپل میں نے آپ کو بتایا تھا کہ انجینئرنگ سلوشنز ہو سکتے ہیں، اور ایجوکیشن ہو سکتی ہے کہ وی کین ایجوکیٹ ڈرائیورس ٹو ہینڈل دیز کائنڈ آف پرابلمس، اینڈ وی کین ہیو انفورسمنٹ لائک کہ پولیس وغیرہ اس پہ فائن وغیرہ کرے، اور وہ ایک آپشن ہو سکتا ہے۔ اور بھی آپشن ہو سکتے ہیں کہ آئی ٹی ایس ہو گئی، ٹیکنالوجی ہو گئی، اس کا اپلائی کرنا کہ کس طرح سے ہم یہ جو اوپر ہم نے ڈرائیور بیہیویئر کی وائلیشن اور ایررز وغیرہ ہیں ان کو کیسے ہم کنٹرول کر سکتے ہیں۔ تو یہ ایک ماڈل ہم نے سیٹ کی ہے۔ یہ سب سے پہلا سٹیپ ہے کہ اس میں ہم ہیرارکل اسٹرکچر جو ہے نا وہ سیٹ کرتے ہیں، اس کے بعد پھر نیکسٹ پروسیڈ کریں گے۔ جس میں ہمارے پاس یہ اسکیل کا آپشن ہے کہ آپ کون سا اسکیل ان میں سے یوز کرنا چاہ رہے ہیں۔ 5 پوائنٹ اسکیل ہے، اور 6 پوائنٹ اسکیل ہے، 7 پوائنٹ اسکیل ہے، 9 پوائنٹ اسکیل ہے۔ ٹھیک ہے جی، اس میں ہم 9 پوائنٹ اسکیل اگر سلیکٹ کریں تو وہ ہمارے پاس اس طرح کی ویلیوز آئیں گی، جس میں میں نے پہلے آپ کو اسکیل سلائڈز میں شو کی ہے کہ جی 1 کا مطلب ایکول امپورٹنٹ ہے، اور 1 اینڈ 3 کے درمیان ویلیو ہے جیسے کہ 2 ہوتی ہے تو وہ ہم انٹرمیڈیٹ کہیں گے۔ اسی طرح 4 ویلیو جو ہے وہ بھی انٹرمیڈیٹ ہے، 6 بھی انٹرمیڈیٹ ہے، اور 8 جو ہے وہ بھی انٹرمیڈیٹ۔ سو دیز even values are intermediate values, and these 1 3 5 7 are these are the main values we select, depend upon the expert opinion that which value they want to give to importance one factor to other. So 9 means extremely important. So these mid values are more important. It shows that how much importance someone give to one factor to other. So 1 3 5 7 9, these are the main values to give the options to the selector, and we can explain to expert that these values, from these values you have to select one value, and based on these numeric values we go for final judgments. So this is the scale selection. You have these options, and then you have option to go for next. Here you can see the all pairwise comparison of our factors. Here in table 1 it shows the pairwise comparison with respect to driver behavior factors affecting road safety. So these are the main factors you have in hierarchical model: lapses, errors, violations, and in next you can see pairwise comparison with respect to violations, in which we have two sub factors: ordinary violations and aggressive violations. And in alternative we have main three factors: engineering, education, enforcement. And this have further we can say that alternative pairwise comparison with respect to errors, that if someone want to control errors, then which technique has more importance than the other. Similarly, with respect to ordinary, there is a scale. With respect to aggressive, there is a scale. Then from these scale, yes, we can give opinion of experts. For example, here we have other option to add expert, delete this expert, save this expert. So these all options are available. There is also expert status that if he has filled the whole this questionnaire or still missing some values, then we can. Then there is option of inconsistency ratio check. As I told that inconsistency ratio, we can check that how our results are reliable or not. Then we go for mean, and based on the mean values, we calculate the final weights. In first, if we say that we give some values that based on these we rank the criteria, then we can say that in lapses and errors between these, which factor has more importance than the other. So if we say that the lapses have more importance three times, mean that it has moderate importance than the other. So lapses, if we select three, then it means it has moderate importance, more importance than the errors. If we compare lapses with violations, if we say that both criteria are important, then we can give value 1. Or if we say that violations has more importance than lapses, because violations are done more by the drivers, so we say that okay, -3 we give value because violations has a reciprocal. So we start from left to right, that's why we give negative values. So if we compare between errors and violations, we can say that the violations are have much more importance than the errors, so we give value 7. So if we give between ordinary and aggressive violations, if we give -9 values, then it means that ordinary violation has very weak importance than the aggressive violation, and we also know that these aggressive violations are more important than ordinary violations. If we go for comparison between education and engineering, and if we say that with respect to lapses, which factor alternative or have more effective, then we can say okay, in this case, if someone has a problem, mental issue to forget some things, then maybe engineering problem can be more effective, then we give value 5. And if we say enforcement and engineering, which one has more importance, so we can say that engineering still have more importance than enforcement. And if we have education and enforcement, this pairwise comparison, then we can say minus, for example, 5 values, that enforcement is has more importance in this case, because lapses person, if have education but it's not about education, he may have to be controlled by engineering or enforcement solutions. So this pairwise comparison, if we go with respect to errors, then we have to select which one has more importance and how much it affect to control the errors. For example, in comparison between engineering and education, we say that if we want to control errors of drivers, then engineering is more important or education is more important. So it's about misunderstanding that if someone don't measure the distance correctly, then it's not his fault, but it's his mistake. So the solution can be engineering solution can be more effective for in this case. In case of between engineering and enforcement, we can say that both have equal importance, then we give the digit 1 from this 9-point scale of fuzzy scale. And if we compare between education and enforcement, then we can say that enforcement has more importance than education. Then we say that -7 said that enforcement has much more importance than education. So I already told you that we give some negative value if the second number has more importance than the first one. If first one has more importance than the second one, then we give positive value. But if second factor has more importance, then we give negative value in the software. Otherwise, you see 1 by 3, 1 by 5, or 1 by 7, 1 by 9 are the options in general table. We understand that if someone has one factor has 3 times more importance than the other has 1 by 3 less time importance than the other factor. So if we consider next step, alternative pairwise comparison with respect to ordinary, here we see that between engineering and education, which will be more effective. So if we say that education is more important, then we give -5. And if enforcement is much more important than engineering, then we can say that -7, for example. Similarly, we have a comparison between education and enforcement, and we say that education has more importance than enforcement. Then how much we know that 5 has a bit more important than one value to other, and 3 has a moderate importance than the other, 7 has high importance than the other, and 9 is the extreme high importance of one factor to other. So here in table 6 we see that alternative pairwise comparisons with respect to aggressive, and we know that the aggressive violations are the mostly done by drivers, for example, to speed limits break, and similarly they don't follow the traffic signals. Then we have what solution we can propose. For example, between engineering and education, if we say education has more importance, then how much if we give 7, that it has much more importance than engineering. And enforcement and engineering, if we say that enforcement has very high extreme importance than the other. Similarly, if we have comparison between enforcement and education, and we say that the both have equal importance, because in some places education is important, and if some cases, if someone fear of fine, then it's also important. So if we give value 1, then this is the whole scenario which we can say that we can fill all these pairwise comparison. So this is the entry data step. Here we can add more expert. For example, we have 10 expert. We can add here each expert one by one, because each expert has its own opinion and comparison between two factors. So I show you here, you can see that expert 1 we added, and if we want to do some analysis, we should have at least 20 experts and more than 20. Some people may use 50 experts, some people use 100, but this is mostly decision makers of a particular. If this problem we have road safety, of course we have road safety experts, and we know that the road safety experts are from the road safety department, and not everyone can fill this kind of questionnaire. So if we proceed, for example, if we here proceed from this expert opinion, then we go for next option, and then we can here see, you can see that this was the hierarchical model in which the main factor was driver behavior factors affecting road safety, and these were the three main criteria: lapses, errors, and violations. And these sub criteria of violations were ordinary violations and aggressive violations. And these pink color boxes show the alternatives, that what can be solution to control these criteria. For example, engineering, education, and enforcement, as we call these alternative 3E rules. These 3E rules is a common term used in road safety. So we know that engineering, what does it mean? That some engineering solution, someone gave that if a pedestrian have problem, someone gave engineering solution that if give zebra marking or somewhere overhead cross bridge. In education, we can educate about traffic rate, safety rules to drivers. In enforcement, we can have fine, or we can give different kind of instructions to the drivers to follow the rules. So in priorities table 1, with respect to driver behavior factors affecting road safety, you can see the weights. The results show from the main criteria that the rank is given to 1, errors 0.813. This is the most significant criteria based on the expert opinion, and lapses has this factor 0.127. Violation has ranking 3, it has less weight 0.06. So this was one expert opinion only, but it's for the purpose of learning. Otherwise, I inform you that we should have number of experts more than 20. So if from this software, it help us to show in the figures also we can use in our research. You can see that these weights are automatically measured. I did not perform the calculation that to divide this value to this, and how we take the mean, and how we calculate manually, but the software performs for us. So in second table, we see that priorities with respect to violations. We see aggressive violations have weight 1 as compared to ordinary violations. Of course, these aggressive violations have more effect on road safety, so it gets the value 1. And the weights with respect to aggressive, if we say that engineering solution is helpful to control aggressive violation, or education is important, or enforcement is important. So it shows that enforcement has the highest weight. So we can say in our region, you can say that enforcement has the only solution. People don't follow rules otherwise, and we can enforce them to follow the rules. It has also this figure, and then we proceed to table 4, which shows the weights with respect to ordinary violations. For ordinary violations, the factor education has highest weight 0.657, and second we have enforcement, in third we have engineering. Actually, in the roads, we can't go much of engineering. We mostly use traffic lights, traffic signboards, and these. That's why sometimes this education enforcement are continuously applied methods as compared to the original methods which applied. So in table 5, we have weights with respect to violations. Here we see that for violations to control, we have highest weight for enforcement and education, while engineering have ranking 3. In case of errors, if we want to control errors, then the table shows that enforcement has also ranking higher than other factors as compared to education and engineering. But to control errors, engineering has 0.331 values, which is ranked second, and education is ranked third. And here we see that engineering is maybe only solution to solve these kind of problem like lapses. If someone forget to where he park the vehicle, then he may have some engineering solution, some device where he can press the button and vehicle sounds and he can find his vehicle because it's related to mental. So education and enforcement is not much more effective for him. So this is the procedure for to measure these factors weights. For example, if we have table 8, it shows that the weights with respect to driver behavior factors affecting road safety. This is the all about weights which we get final weights. So I inform you that this procedure is that global weights we give them ranking of the factors. So these are the global weights. Here we have option to download in Word document, and we can download in Excel, and we can print our results. So this software is very helpful to perform these kind of analysis, and we can use in our research these kind of analysis. So this whole procedure, you can say that similarly, you can have criteria, sub criteria, and alternative solutions. More if you want have about 10 factors, 15 factors, then you can still analyze in this software, and we can have a solutions. For example, here I just show example. Otherwise you can have lapses option 2 to 3 sub factors. You may have errors 4 to 5. Someone inattentive during driving, someone misread the distance between vehicles. This is also errors. In violation, we can have many violation types. You can have sub-factors. Similarly, in engineering solutions, you can have different sub-factors. Someone say that if you want to give traffic light signal somewhere, someone say give road marking. This is also engineering solution. Someone say give signboards. This is also engineering solution. In education, we can have road traffic safety campaigns and visit of schools and universities. We can educate different people and in the camps alongside the road. In enforcement, there can be different solution, and traffic police can enforce the traffic rules. So it also has different options. So this is the whole results chart in which we perform the pairwise comparison, and from these results you can get your task. If you want to change some values, then you can go back and you insert the different responses of the experts. For example, here if I want to insert like and I want to insert another expert, then you can see that the window change show that put the responses of the other expert. And if we want to save this expert, then we have option to save the expert opinion. Then of course we have here option of expert one, and you see this is already saved, which we already performed the analysis based on his opinions. And in expert 2, if we have these values and we say that what is the expert status, it shows that expert 1 has completed his responses, and expert 2 it shows incomplete. So it means that if we have option of this if someone has incomplete responses, then still it shows that he can fill the whole this questionnaire. So in this manually, if someone have Google Sheets to get the responses of expert, then he can also get responses and insert in the software one by one. Because everyone don't know to how to use this software and perform analysis, so we can get the questionnaire results and we can perform analysis ourselves. Therefore, it's better to develop pairwise comparison in Google Sheet and share the link with the experts. If you want more reliable results, then you can go individually and get the interview from the experts and get the responses of each expert and then perform fuzzy AHP analysis or any multi-criteria decision-making analysis which relate to your problem. So here we can see that we have this option to go back also. So if we, for example, want to delete this expert, there is option yes, you can delete it. Then we can have only one expert, for example, in the example. Then we go to check inconsistency ratio. For example, I already told you that the if number of responses should not be very low and not very high, then it affects the reliability consistency of our results. Here you can see that CRM and G are the two values for table 1. It shows higher value and it show inconsistency matrix because we here insert only one expert, so it also affect our results. In second table you see that CRM and CRG as zero value, it shows the consistent matrix. And in third table you see 0.48. I already told you that these values should be less than zero point 0.1, less than 10%. So if we have greater than 10.1, then it is inconsistent. Here you see for table 4 we have 0.013 and 0.037. So these values are less than zero point 0.1. So these are the, it shows the consistent metric. So if someone has inconsistent results, then he can go to change the values again, and he should get the consistent results at the end. So it of course depends that how the experts have experience and how they fill the questionnaire. Sometimes you see that such kind of questionnaire, people ignore that questionnaire and they just insert the random options just to fill the questionnaire for the sake of questionnaire. But in case of expert opinion, should have the very reliable results because this will affect our decision making techniques. And therefore, these techniques are very helpful. And this software you have other options to apply. For example, these all techniques in topsis technique, fuzzy topsis techniques, vicure, fuzzy vicure, and demetal, fuzzy demetal. These all techniques have a similar options like in which you can say that in these techniques we develop the AHP model, then we perform pairwise comparisons, then we calculate the weights, then we check the consistency, then we may apply sensitivity analysis. So these all results are possible to find from these all criteria. So this final weights are important, and this development of model is very important. That how we calculate these weights, and how we rank these criteria. So, based on expert opinion, if someone has shows that this factor is more important, then of course authorities and the department should focus more on those factors instead of the other factors, because these all need time and resources, that how to focus on which criteria and how to apply which technique to solve these kind of problems. So this is very helpful technique in which we have this automatic procedure in which pairwise comparison are performed and get the final weights. So this alternative, you should keep in mind that these are the different in color, and these are not the criteria, but these are the measures and the solutions we get from these criteria. So this procedure you can apply in your final year projects, and also you can use in research papers. Here, for example, if I go for option to download in Excel form, you can see that it comes here, and we can download it to show that this Excel form we how we get the results. Also, we have different options to get the results and download Word document, and we still can find that this file in the Word document can also be helpful while using in the research paper, for example, because here only we can get screenshots and images from this software, then it is not acceptable in case of research papers. That's why we should have in Excel form or in Word document. Therefore, we have option in this software to get in Word document. So I inform you that this software is also use full version in which we have a number of we can insert number of more criteria. In demo version we can have a few criteria and few factors, but if you purchase for 1 month, it shows that we can have full version, and we can apply different number of analysis. If you can see from here Excel file, you see that the whole procedure and weights are here mentioned, that which criteria is we get the results. You can see that we have these criteria, lapses, errors, violations, and from these criteria we can give the importance which have more importance to the other. Similarly, in Word document, we find here the file, and it shows in a very in a nice way that these are tables, and we can edit these tables, and each table has its description on the top, and we can say that with respect to which criteria this has get the weights, because you see that in every table there is written engineering education enforcement, but we can highlight that according to ordinary. If we want to board it, we can say that this is according to ordinary, and if we can say the according to violations, then we can highlight it, and we can say the engineering education and enforcement according to these factors, which has more importance in the way to control these driver behavior. So you can use in your own case that how you can say that in different projects you can use multi-criteria decision making techniques, and